So I had a request for this project, and I appreciate David. He asked me for some working drawings for a project that was similar to the one that I did for the Army. When I say for the Army, I actually was helping Chief. How I was helping out Chief was that the process, in the military for getting design work done is really tedious. So what I would do is I would help him with this type of design stuff so that they could go out and do things quickly and they wouldn't have to wait on the long drawn out process. And usually the buildings I was helping him with were temporary anyway. So the reason I'm explaining this is because I can't just sell any of these packages and these drawings the way they are for other people, and I'm going to explain that. But I think that's a bad idea in general, because each project really should be designed independently and for itself, for that particular project. It's a bad practice to start kind of rubber stamping drawings, and design for different projects. And let me go in and turn off my metal roofing and the decking. The Army was working with, on this particular project, they would get these containers of 16-foot material. Okay, so they didn't have any choice, right? I mean, this container would come with so many 2x8s or 2x6s 16 foot long, and that was it. You just had to deal with it. So what I did was I took a 16-foot, I think these are 2x8s or 2x6s. See, that even makes it worse. And I stretched it out as far as it would go. You can see that's 16 foot exactly. So the idea would be that I made the pitch low enough, and I think this is like a 212. I made it low enough so that the rafter would be long enough. And the reason I knew I could get by with that is because I had this bearing point midway on each rafter that I could put this little leg, stiff leg in, and I knew then the rafter was really only spanning about half that distance. But what I didn't like about it was this little wimpy overhang that they had, as a result of only having 16-foot material, because they had to have 14 feet between here to get their whatever trucks, I don't know if they were using Humvees or what, in here to work on them. And that was the whole point of this. So this is not a good design for, a civilian. These weren't even good designs for the military. It's just it was out of necessity. Now I think it's a good design for what we had to do, and it worked. But it's not. Wouldn't be good for civilian use, and that's the reason I'm not being like obstinate by not selling people these designs. I'd be happy to. It's just I have a conscience, and it's just not a good idea. I'm going to show you a better design, and this one was really hairy to me. They would stack up two containers, and I'm not sure if this was because they were trying to put a howitzer in there or what. I only got the information I needed to have. These things were top secret missions, and I didn't get any of the top secret information. So whatever they were putting under here was tall, but this is very precarious. And I told Chief, if you ever have a big wind come along, it's going to rip this thing right off. So, and that's the other issue, is that since these were temporary buildings, they weren't exactly, we had these fastening methods, but I never knew if they were going to be carried out or whatever. So I'm basically going to delete all of this. Let me fix this style so you can see better. Yeah. Which one do I like? There's a certain one. So you're going to have to, I think David said his was not going to be on a slab, but you'll have to have these bearing points, because I still question the load bearing capacity of these walls. These are basically just, you know, steel, corrugated steel, and there's no structure on the inside of these, you know. And I know people are going to say, "Oh, they're really strong." Yeah, they are, but you need to have points along here that are load bearing. I would say at least one on a 20-footer. You should have one in the middle. I wouldn't be, spanning this. The way these are designed is that the corners are what's load bearing. People get this mixed up. These points, see all these locking points, these things, when they're stacked up, the load is transferred to the corners. It's not spread out along the length of it. Of course, it's the length of it's only carrying what is in its container. When you start stacking these up, it's just the corner that's taking the weight from the one above it. It's not, so it's not like this is designed to have 20 containers stacked on top of it. This part of it, it's designed to be stacked, because if you'll notice up here at the top, these stick up. So we're actually creating a load bearing condition when we put this 4x4 on here. Now we're creating a load bearing condition, but we're spreading it out over the length, so it should be fine. So I guess I've done enough talking. So basically this roof is going to go bye-bye. So now we can see how these 4x4s are attached. You just weld on some kind of plate steel. I think this is like a 2-inch strap by 8 inches maybe. Yeah. So you can get some 2-inch plate, flat bar, like a 1/8 inch thick, and just cut it into 8-inch pieces, and you can you'll have your straps. Because this is a big airplane. Okay, don't be fooled by this. This roof is acting as a big wing, and if you have a big wing coming along, it's going to be lifting. There's going to be a lot of uplift. Okay, so if this thing's going to fly off, you want the containers attached to the roof as it goes. Maybe it'll land in an upright position somewhere. But anyway. So we're going to start off with this, and I'm sorry about all the zooming I do, but you have to understand that I have to be able to see. I get all kinds of complaints about this, and I understand, because I watch my videos, before I release them, and I understand, but you have to understand too that I have to be able to see what I'm doing. What I am trying to do is get out of the habit of, while I'm talking, doing this, so I'll try to do better about that. But I just have to get things situated to where I can work. And this is all about working. The video comes second to me being able to do this efficiently. So one thing I wanted to introduce in this video, I've used this before, is the Medeek extensions for SketchUp. They have some really nice ones. They have Medeek foundation, truss, and wall extensions. And of course, these truss extensions have actual engineering applied to them. You see a lot of these extensions in SketchUp that are just, shortcutting the drawing function for you. Well, these actually have, calculations, load-bearing calculations behind them, and these webs are all, accurate. You could take this to a truss company and say, build this for me. So anyway, I'm going to just pick out this typical truss here, and I noticed that they don't have any. One thing I'm going to request is a drop truss, and I'll have to draw it, which is no big deal. But I'll show you that in a second. So I'm going to pick this one, and let's see, click front left corner. So I'm going to go from here over to here, and we're going to go back to here. Now, truss type Fink is fine. Let's see if they do have the drop. I'm just going to do a Fink. I think is that configuration I was showing you. Out to out span 30 feet. Now I think I like a 16-inch overhang on this size building. Let's see, top chord pitch. Let's go with a 3. And I meant to ask him about this. I think on this kind of building, you want to kind of keep. Let's see, we're gonna have a 15-foot. Sorry, I'm thinking out loud here. I've got 30 feet, a 30-foot span. That's 8 and 8. That's 16 and 30. That's right. So I've got a 15. Actually, I have a 15-foot span. So 15 times 3 would be 45 inches. If I leave it at 4, that's 60 inches. So you're looking at basically a little under 4 feet versus 5 feet. And if we'll leave it at 4 for now. That way, let's see. He said he was going to use metal though. Let's try to save him a little money. And if he doesn't, if you don't like this, Dave, I can fix it. But you can easily do a metal roof at 312. I just think keeping the roof down. You wouldn't want to do like a 12-12 pitch. You don't want the roof area to be larger than the building area. That's kind of a general rule of thumb I have. Top chord size 3.5, bottom chord. This is what I like about this Truss program, this extension. You can actually give it the chord sizes. Plywood thickness, ply thickness, 1.5 inches. Okay. Building length is 20, that's correct. Truss spacing 24, that's correct. Gable end trusses, yes. Let's see what that does. Here we go. Thank you, Medeek. So gable stud spacing, let's do it at 16. And then average advanced roof options. Let's see what those are. Let's see. Yeah, we'll see. Sorry I'm rambling here. I've only used this a few times, and I think he's updated this, so it may have some better options than I've used in the past. The reason I want these studs, gable end studs, and I'll show you this in a second, to be on 16-inch centers is because I'm going to suggest maybe doing some board and batten in the gable instead of lap siding, and that'll those 16-inch centers will work out better for that. So let's see what kind of advanced. This is on these outlookers. I like to actually drop the truss on the end, and I'll show you if they don't have that option. I'll just manually fix that, or not fix it, but do it. Roof sheeting, let's go ahead and say yes. 7/16 good. OSB. Gable wall sheeting, yes. Wall sheeting material, OSB. Subfascia, yes. Drop. Fascia width, yes. This is one thing about Medeek, is that they actually know how things are built. And I can tell by going through all these specs. 7/16 OSB, that's a common, all of the stuff is common to modern building construction, and it's very refreshing to see that. Rake board, yes. Gable overhang 16. We call it the barge rafter. The reason we call this, what they're calling the rake board, a barge rafter, is because it's the rafter that hangs over after the house line, and it's just like a subfascia. It's akin. It really is part of the subfascia system. It's not like an exposed member. It can be, but it's not typically exposed. It's usually covered up with a fascia board. Outlookers, yes. Yeah, see, these guys know what they're doing. Horizontal or vertical. I've done this both ways, where you can lay the outlookers. They're better like this, vertical, instead of horizontal. Horizontal would be flat. Now I'm assuming, I want them vertical. If this doesn't work out, we can always change it. Cladding, Roof cladding, yes. Material, let's just call for corrugated metal. There we go. I'm not sure if he'll have gutters or not, but what we'll do is leave them there and then go from there. Now, what I really wish I'd done is left that, because I really think this is kind of a paint lap siding in the gable like that. And I'm surprised, I thought we had a soffit. Let's go back and check. I think what I'm going to do is take off the siding. Okay, so I finally got my layers worked out. I had to become familiar with how Medeek does their layers, and so I kind of got that figured out. And one thing I wanted to show you is and I appreciate this about them, they have these options with these soffit, these outlooks blocking. Is there's two different ways to do this, and there's one way I really like to do it, and I'm going to show you. This is the way a lot of people do them. They will have this house line truss, and it just occurred to me that is going to need to be a structural truss. The best thing to do here is probably run let me think about this for a second. Typically, this house line, what I call a house line truss, is sitting on top of a wall all the way. It's not load bearing. And so we can get by with just these vertical members for nailing your siding onto, your sheeting and siding onto. Well, in this case, it's got this span here, and what we may want to do is just this may seem like an overkill, but we may want to just put a truss up beside it. I may look at that. I'll look into that and see what the best way to do that is, and get back with you, David, on that. But the way I like to do these is actually drop this truss, and again, this method would be, this truss would be at the same height as these. They basically are built the same. They just don't have the same webbing, the structural webbing that distributes the load across the truss, the bottom cord there. They basically have vertical members for nailing siding onto, and that's generally, like I said, because they're not load bearing across the length, here. They're usually just sitting on top of a wall. But the way I like to do it is I actually have what I call a drop truss put here, and it's basically 3.5 inches shorter. And thankfully, where is it here? We have, and I figured it out because I went back to structural outlookers. Yes. So if you say yes, what that does, and I'll update this, it actually drops the truss. I don't know if you noticed that. It actually drops the truss like it would be, and then that allows you to run your I keep wanting to say outriggers because it's what we used to call them. These lookouts, these blocks, they run from here out to here, and that's exceptionally strong, okay? Because now they're sitting on top of this truss. They're not just nailed into the, toe-nailed into it. And they're cantilevered back here to this truss. So by way of the roof decking sitting on top of that, where's our roof decking, roof sheeting? Here we go. You see, there's really no way that can droop down. And this really comes into play when you have like a large overhang, like a 2-foot overhang. Now, I am surprised when you say yes on the structural lookouts, different parts of the country have different terminology, then the sheeting should be down in that case. So in that case, the sheeting would be, down here underneath like that. So you just have to, I may have to fix that, or I'll just leave it alone, and you understand that the sheeting just goes up to the bottom of the lookouts there. It would be cut to where it just goes up to here. So that's your two options. The I guess you could call it cheaper, faster way is if I just undid that. Go back to see. You really can't tell that it just popped up, but the truss just popped back up to be, even with the tops of these, and then these blocks are cut off, and you can see that doesn't allow as much structural. This is basically just hanging out here now, and you don't think it's much, but if you drive down the road and look at all the houses that have drooping soffits, overhangs on the end, you'll see what I'm talking about. You'll see these sag even along the length, especially if these get kind of long, like 16, 18 feet long. You'll see a sag in the middle of this because there's really nothing holding it up. And so probably what I'm going to do is go back. Let's see if I can redo that. There we go. Thank you, redo. And that's the way I'm going to suggest to do it. And in the long run, it does, it's up to you how strong you want your overhangs. And of course, to tie these trusses off to this 4x4, you would have some kind of what we call hurricane tie. It's just a metal, typically Simpson makes these things, and there's different types, but it's just a metal tie that ties your rafter, mechanically, your truss down to this 4x4 here. Now, one thing this is not showing, and I need to go back and look, is there should be a purlin down the middle. And I'm just going to go ahead and show you what it looks like here. I'm just going to draw, let's see, what is that? And then we'll pull it up 1.5 inches. Yeah, that'll work. So there you go. You can see how having to draw things individually takes so much time. I was able to create this whole roof system in probably half the time it took me to draw that bracing. What that does is it gives your roof system lateral bracing this way. When you're setting your trusses, you'll have this brace and it'll be laid out, 24-inch centers where your trusses go, and then you'll nail up through here into the bottom of your truss, and so it'll help you while you're installing the trusses keep them on layout, but then it'll be a permanent brace also, and that just makes your roof really strong and keeps it from having this lateral. I've actually seen trusses fall over and they just lay over like dominoes, and that's because they were insufficiently braced and the wind came up, and of course they were taller trusses that caught the wind, and just all laid over, and it was a mess, because when you raise them back up, the nails would be out of this plate, so you'd have to pull all the nails out and reset them. So that's what I would recommend on the trusses. And then, so what I'm going to do is, let's turn our layers back on. We got our gutters, and I'm not sure if he needs the gutters, but that would be gutters. And then our roof sheeting. And of course, that's just, 4x8 sheets. I wish I had deleted my roof sheeting because I actually show the pieces. Just like that. See, that'll give you that gap, that air gap you need, that continuous gap at the top for your ventilation. So there we go. So all I would have to do is so what I think I'm going to do is send this to David and see what he thinks, and I'll send it to him in several different ways. I'll show him how he can get online and see this, and I'll also send him some paper drawings that he could print out. Okay, well, this first video was probably long, but I wanted to knock out most of the drawing part of it, and then I will get some updates from David on how he wants to proceed with this, and part 2 will be finishing it up, and I'll show you how I lay out the drawings. Thanks for watching.